Okay, so pause it so that you can view it and do the problem. But right now I'm going to do it. Okay, it is said that in the current .com boom, this is an older problem now, the annual turnover rate of IT personnel is 10%. A firm has 110 IT personnel. What is the probability that 15 or more of these will not be working for the firm 1 year from today? Okay, so 15 or more, x greater than or equal to 15 out of 110 personnel. Probability that any one person will not be working for the company a year from today is 10% or 0.1. Okay, in this case n is large, so you think either Poisson or binomial. P is not exactly towards the middle of the distribution, but if you do that in your head quickly, the n times p would be 11. 11 is greater than the 7, and the Poisson requires that the maximum mean is 7, and that's not happening here, so the normal approximation will be good. So we'll write it down though, check for the normal approximation. Sometimes you'll have problems that could be done either way with the normal or the Poisson. Okay, in that case, since it can be done either way, you have a choice. So anyway, the n is 110 greater than 50, so that's good. The mean NP 110 times 0.1 is 11, greater than 5, so that's good. Alright, so as I said, the normal approximation is good. Alright, what do we do next? Well, first thing we do is to write this with two proper limits on the binomial. So it goes from 15 through 110. Alright, everybody could turn over. Where the n 110 p 0.1. Alright, before we go to the normal approximation, let's calculate the standard deviation, square root of np times 1 minus p. So it's 110 times 0.1 times complement 0.9. Don't forget, of course, to take the square root. So this is the square root of 110 times 0.1 times 0.9, 3.146. So our normal distribution statement will be approximately equal to going from down half a unit from the lower limit, up half a unit from the upper limit. The mean is 11, standard deviation 3.146. Diagram. Mean of 11 going from 14.5 through 110.5. Again, it's the area on one side of the mean. Alright, and we find the corresponding values on the z-distribution so we can find those probabilities. Alright, so again, x minus mu on sigma. X, the lower limit in the first, 14.5 minus mean of 11 divided by the standard deviation, 3.146. Alright, 14.5 minus the mean of 11 divided by standard deviation, 1.11. And then the upper limit, skip the formula, it's 110.5 minus 11 divided by the standard deviation, and that's going to be so far out there, it's going to be off the chart. 10.5 minus the mean of 11 divided by the standard deviation, 31.6, yeah, 62. Lower limit 1.11, upper limit 31.62. Alright, so as before, we go from 0 to the upper limit, which again is approximately half, then subtract out this part here. Sorry. Not that it matters a whole lot, 31.62 minus then the area probability from 0 to 1.11. So from 0 to 31.62, since it's way off the chart, is approximately a half, and then to 1.11, 3665, and that should be something like 1335. Alright, so there's a 13.35% chance approximately that 15 or more of the IT personnel from that particular firm will not be there a year from today. Alright, that's that problem, and that's the end.